calculation, then it will do with the after decimal, it will truncate, let's say, after 10 digits, or in double precision, it's 16 or 20 digits. So, because if you are multiplying some quantity and they are very small quantity, so wherever you think that the major accuracy is required, you can always do the calculation with double precision. Now, what's the and then how you are going to do the calculation? First thing, double precision, like if you have to write the some number like 3.4, so you have to write 3.4d plus 0. That is how you have to write. So the quantity that you write, initialize, you have to write like plus n point and d. So that means these are the digits. You can put some digits before decimal and after. Now you can see I have written this 112.52121 d plus 04. Now this is a double precision format in which I have written this. And the next quantity is the same with minus sign plus 4. Now you might think I have given only the after decimal 5 digits. Then why I'm talking about the 10 digits or 16 or 20 digits? You know, that means when the calculation is done, how you do the calculation? Like sometime, you know that if it is, if I ask you write only up to first decimal place. So if you get a quantity 10.56, so you will say it is 10.6, or 10.58, so you will say 10.6. If it is 10.52, then it is 10.5. So similarly, when the calculation is done, you must be knowing or not, then that after every expression is evaluated, then it truncates and makes it after decimal 8 decimal points, normal, single precision. And if it is double precision, then it is 16. So after 16 decimal, it will consider and then truncate. It's not necessary that you, like if I write D here and put 12 decimal places, then it will take it in the calculation. But while otherwise, if you write in single precision, which is normal programming, then it will say that you cannot take after decimal. But so you might be thinking, it's a good, what is harm in doing it? But you see, it will take just double memory. If you can store a single precision quantity, if it takes one memory, then it takes the double memory. So the double memory reserves once you say that it is a double precision quantity. Now how we use it? So the you can't write in your like you cannot write. Let me. You cannot write like if you write the quantity simply saying that it is 112.521. Then it will say, okay, it's not a double precision quantity. So you have to be, you know, even like if you write 112.0D or 0.0D. So you have to put a D type of term there. So what does it mean? Variable needs to be declared that which quantity you want to calculate in double precision. So you have to declare, like you declare real double precision. So double precision list of variables. So list of variable you can use. Like I say, double precision, term, D and diff. These three variables should be used as a double precision in the calculation. So if you have a dimension, then you can just term in the bracket 10. So that means it will have a dimension term 10. So dimension together with declaration is preferred. Or if it is not a dimension quantity, so no array, then no need. So double precision expressions are formed according to the same rule as further, and thereafter there is no difference. Double precision quantities can be mixed with real quantities, and their power cannot be raised by a complex number. Like you saw that in a real quantity, we could raise the power by any decimal quantity, but if it is a double precision, then you cannot raise the power by complex number. While if it is a real power, you can always raise the power. So remember that double precision does not allow raising the power by a complex number. So here is an example of a program. So I want these variables to be double precision, C4, C5, C6, 7, RST. So I have declared this double precision blank and list of variables separated by. Now when I do the calculation, here I have used 6.3, not a double precision here. Now if you have written here these quantity as a double precision, like if you have written here 5 and here written R, then it becomes automatically 5 point, even it is integer. So similarly, if it is a declared double precision quantity, then all the calculation it is, so it allows you a mixed mode. Mixed mode means you can use some of them as a double precision, some of the right hand earlier used to be that you cannot even mix this, but now there is advancement, like now it is already 15 years that mixed mode has been allowed. Earlier also, like real and integer could not be mixed. So the computer are day by day becoming robust. So all arithmetic operations are carried out according to right-hand sign expressions, and the result is converted according to the left side variable. So result will finally be converted by these variables which are declared. So if it is a rest of the quantities will remain in the program as a single precision. Only these quantities which you expect that some expression might be required to be calculated accurately, then you can use the double precision. Fortran provides library function for double. So all the library function, all the built-in program for double precision would be like, if you want to do a square root, so you write DSQT and in the bracket something. Like if you want to take the absolute value, so DABS. So in most of the cases, you put D in the beginning and do. If you write AB, if you do wrong, like I have declared R as a double precision quantity, I write absolute or, then it will say, it will give you a syntax error in your program that a wrong operation is done here. So the quantity's absolute value is not taken correctly. So be sure that like X is declared double precision, then you can use the D sign. Now data also, double precision quantities can be read and written using D format. D format is exactly like a E format. So here there is no provision of writing F format. So F format is not there. I format is not there. You have to use D format exactly like you use E format. Simply replace the D, E by D. So that means here the total width, D right here, total width. And so how many quantities you want right here? Like 5D, WD. So here is the total width, and after decimal, how many places you want. So that is, so let's see this program in double precision. So I have two equations, AX plus BY equal to C and A dx plus EY is equal to F. Now I know I can do it analytically, and I know that X will be equal to C minus BF divided by AE minus BD. And similarly, Y would be this. So now I make a program here. So first thing, I want to do the calculation in the double precision. So I declared all the variables here as a double precision. Now I am reading a variable A, B, C, D, E, F because these are not known. Only X, Y are not known. A, B, C, D, so you have to give like in two equations. So I have to read all this A, B, C, D, E, F. So I give a format. So read from unit 5 as per the format 55 is statement number. So statement number is 55. Here I say use 3D 10.4. So 10 should be total width after decimal 4 point, and 3 quantities should be read by this. So there are 6 quantities. So first 3 will be read by this, and then read slash 3D10. That means go to the next line and read from there 3D10. The data, input data would be something like this. You see, I have put here D, 0.4071, so 10.4. So 10, the total width should be 10 here. So gap comes because I have written here. So these are all written 10, 10, 10, 30 columns used here. So after 4, instead of D, the E, I have used D here. So D can be used in this way. And second line it comes, so it reads A, B, C, D will be given this value, and D, E, F will be given this value. So this, then I calculate X, Y is also, because if these are double precision, and if I put single precision here, they will truncate to the single precision. So I have to put, now these quantity, I can then write these expression. And when you write this also, so you have to use write according to 77 format, write two quantities, the solution. Now I give the format 77, 1H, that means of this is a blank. So whatever you write, like if so it gives one gap here, and then 2HX, that means two gap, leave two gap, and whatever is written it takes, so it will be X equal to. Now this format is for reading X. So it reads with 30.20. So you see 20 decimal places you can achieve from there. So total column should be 30, only single quantity. Then give gap of 5X, 5 columns, and then write 2H. So after 2H, 2 columns will be as such written. So Y equal to, and then I have given this. So this is how you can write and stop end. Okay, so this was a double precision, and in double precision, all the quantities D sine, D tan, D absolute, D square root, D log, all those quantities will be just added. D will be added to it before, and then take that. Okay, so this is one thing that you can remember. Now, I have not told you about how to handle the complex number. So complex number is very important. Complex number is very important, and maybe a few years back, the complex number, when I was using it quite some time back, when I was studying, then you have to do complex calculation as a separate real calculation. What does it mean? Like if I say I have to multiply, so I can A plus IB with C plus ID. So if I have to multiply, I separately multiply those and handle the real and imaginary part separately. But nowadays, it's not very early that it was possible, only maybe 10-15 years back only, that every computer has got this facility, that you can treat the complex number as such and do the calculation without thinking, just write it, declare and do it. So you have to be very careful in listening that the complex constant x plus iy represented in Fortran by an order of pair of real constants like x comma y. So whenever you are defining a complex quantity, you have to write x comma y. In some places, in some computer, complex quantity can be assigned a value by CMPLX. CMPLX is not totally. So the first being a real part and the second being imaginary part of the complex quantity. Now, complex quantity clearly requires the value two storage, one for real and one. Like if you want to define the complex quantity, so it will take double of the value of the, like a double precision. But here two storage, it calculates in such a manner that it puts the real part separately and the imaginary part separately. So it will require two. Okay, next point is that the complex variable has to be declared in the type of, just like a double precision, you have to declare in the beginning that which variables are complex. For example, if the variable name ZCXW is a complex and the array name is res10. So if the complex quantity is dimensioned, then you can use this thing. Are to be used in complex. So only these variable will be used as a complex. So in the beginning, all the declaration, real, integer, double precision, complex, all the declarations are done in a computer program in the beginning of the program. You can't do declaration just before you are using it, so that computer is ready to handle these things as a complex. Now computer knows complex blank ZCXW. So these variables, computer knows that it had a double storage for this thing. And this has res10. So 10 into 2, 20 storage for this 10 dimension. So for every complex variable, two locations of the memory are used to store the complex quantity, like for two real variable. That is what I was emphasizing, that you have to. Now, for the complex quantity, any arithmetic operator with plus, minus, star, slash can be used as such, like a real power. For power, star should be used to raise the power of a complex quantity only by integer number. Like you cannot raise the power of any, like I cannot write Cx star 2.0, not allowed. Cx to the star z, not allowed. It only, for complex, you can raise the power only by integer quantity. You can think that that is the problem, or that is the restriction that you have. So never do this. Another thing, no relational or logical operator can be used with complex quantity. You cannot use less than, equal, which is you see, it's a common sense. Like I cannot say for a quantity like 2.3i, I cannot say check whether it is less than with another quantity, because how can you compare two complex quantity? maybe their real parts are equal, maybe their imaginary parts are equal. So never use. If you do this, that means first the computer should say that you are not allowed to use it. It will, but if you do it, it's wrong. Similarly, like double precision, if you want to take an absolute value of a complex quantity, you write CABS, C exponential value, C square root in the bracket, then C log, C sine, C cos. Most of the variables so that means when you are dealing with the complex quantity, you cannot raise the power by real or complex quantity. That is the restriction. You cannot use the logic or relational operator, which is greater than this or that. You can't check it. So all the if statements you are not allowed to use here. Although you can make a first real quantity and then use it. Library function or built-in function has to be used with C in the beginning. So I will show you that how you can use it. Real part of complex number can be obtained. Like if you want to check something, then just write, like if I write x, t is equal to real z, then z is complex. So it will bring me t equal to the real part of z, complex quantity. If you want to extract from a complex quantity imaginary part, then you write AIMAG in the bracket, imaginary part of this quantity. This is purposely done because with I, it starts with the imaginary, so A has been put. So remember, if I write IMAG, it's not going to take. So you can find out, convert the complex quantities real part and separate this, and then check a relational operator or check the power, but not exactly you should use this. So anytime you want to find out the real part or imaginary part of the complex quantity, then like t is equal to something, p is equal to something, so it will extract out the imaginary part and give you the answer. Let's see that how we do the complex number, how the computer does it. Complex number, a complex number is a number z from z is equal to x plus iy, where x first term is a real and the second one is imaginary part, and I is another number, and in computer I is a complex number. So remember, which is, we know that I square is -1. So even if quantity is imaginary, you have to write 0 for real number and imaginary for this number. For example, if you want to declare some quantity complex and you are thinking that it's all purely real, then you can use real part and imaginary part put equal to 0. If you know that there is no real part, so put real part 0 and same. But you have to declare the complex number. So when z is equal to x plus iy as above, x is called the real part of z and y is called the imaginary part of z. So like if I want to find out the real z, then x will be extracted, AIMAG, y, then y will be extracted. And then real, you cannot equate a real quantity by a complex quantity. This mixing is not allowed. While for the calculation, real and complex quantity can be mixed, but you cannot equate a complex quantity equal to something or real. Here it doesn't work. Like if you have integer quantity 10, if you write a real quantity 10, t is equal to 10, then it truncates it to 10 point. But if you do here, like earlier I said that in double precision, if you write double precision and use it, then it does the job. But here you cannot do this. Mixed mode is only allowed in the right hand side. Okay, so let us say that there is a one quantity here, 3 plus I2. So in computer, you don't write like this. You have to write 3 plus 2I. And real part is of 3 plus 2I is 3. And imaginary part of 3 plus 2I is 2. So that is what it means. Imaginary parts means anything you take out the you should be able to write take I common and find out what is rest with the rest quantity which is multiplied. So you should be clear that excluding I, whatever is there is known as imaginary part, or the coefficient of I, which is root minus 1. So now let us do addition. So if I do the addition, 3 plus 2I, 4 minus 6I. So 3 plus 4 is added, real part added, imaginary part added. So this becomes here. In the multiplication, for example, 2 plus 3I into 4 plus 5I. So you see, you multiply 2 first with this, so 2 into 4 plus 5I, and then I times 3 plus 4I. So it becomes 8 plus 10I plus 12I here, and then 15I square, which is then minus 15. So finally minus 7 plus 20. So real part is minus 7, imaginary part is. They are separately stored in the computer. So this is what the value here is for the imaginary for addition and multiplication. Now there is also a command there how to find out complex conjugate. So complex conjugate z plus xiy, its complex conjugate is z star x minus y. So you can find out, like if I have declared a quantity p as a complex, if I want to find, so you can write CONJG in the bracket the complex quantity, it will automatically find this. Let us just two real numbers stored as a pair and treated as a real and imaginary part of the complex by the computer. So like I can write now, suppose you start with, you have declared complex, how will you give the value? So you will write x is equal to 1.234 point minus 6 comma 5e minus 3. So 5e minus 3, e to the power minus 3 is the imaginary part and real part, where 1.234 is the real part of the complex number. Sorry, it is minus 6.5e. So minus this point is imaginary here. Okay, so we write a program of addition, multiplication of two complex numbers, x and y. Also find the conjugate of x to be I star x star y and print the real imaginary part. So let us do it. So assume x is equal to 1 plus I and y is equal to 1 minus I. Now these are two complex quantities. First is, so you have to program for complex number, implicit none. Implicit none means I'm not saying that anything specific declaration except when I say what it is. So if you are not, if you write implicit none in the program, then all the real variable will be taken real. I, j, k, lmn starting with that will be integer. And now I say implicit none. That means follow that, and then complex x, y, I. You see, I am declaring I also as a complex quantity. So how should I write x? X 1 comma 1. So 1 plus I, coefficient of I is 1. Y, so coefficient of I is minus. So y is equal to 1 minus 1. And I is totally imaginary, and that is coefficient 1. So all the three quantities, complex quantities, declared here, and then they are here. Then I can write x plus iy. So if I write x plus iy, if I write x plus iy. So complex number can be added. And you see here, interesting thing is, for real, for complex number, you have to give 2f 9.5. For single complex number, you have to give. So in all the F format and E format, although you are writing or reading one complex number, but your format should be double. If you write 9.5, it's not going to write. It will write only real part, it will leave the imaginary part. So you have to write 2x 2f 9.5, although x plus y is a single complex number. So 2 gap and 2 format for real 9.5 and also for imaginary 9.5. Then I am writing CONJG, complex conjugate x. And then for complex conjugate, like x plus iy will be, so after x complex conjugate, so I have to give 2x is the gap and 2f 9.5. So again the same double format for conjugate, and then I star xy. So it's also like you multiply these two and do by I, it does the job, and it will be a complex quantity. So this thing you can do like this. Print real part of y by real something. So if you want to find out what is the real part, so real y, write real. Here you have not to give two format, because real of a complex quantity is a real number and you require only one format. So you don't have to write 2f. So remember, like you want to find out the imaginary part, then also you have to do this IMAG. So IMAG or AIMAG, you can see what your computer allows. If it says that is wrongly written, then you can put A. And as I said, the variety of computers are available, and everything exactly is not followed. Only the calculation procedure is followed by a language. Now, modulus of, how will you calculate a modulus of a complex number? So denoted by R, you know that a complex number, its modulus is R e to the power I theta. So where theta is tan inverse y by x, and the value of R is x square plus y square. So let us calculate the argument denoted by arg z or arg x plus y for x not equal to 0, because I know the argument will be tan e to the power y by x. So we can make a program here, implicit none, complex quantity is only z here. So real part, so you can define in the beginning, the real is modulus, argument read. So whatever you get from the z value after reading, then its argument is required. So simply use modulus z, write modulus z, write argument z. So you can see that the modulus value is a real quantity, because R is the root of x square plus y square. Argument is also a real quantity. So now, here I have used a real function, modulus z, as a real function. So if your computer does not know what is the modulus, then you can use the complex number here, and modulus is equal to C absolute value of z. So that is how you can calculate it. So I made a little program here that takes account of this. Okay. Similarly, if you want to argument is real, so real part parameter you can give pi, and real is theta is also real. Complex is z. Theta can be calculated a tan ai imaginary part divided by real part of the z value. And then if you want in degree, so you can multiply this is by pi. Pi is already defined. So and this. Now, complex array, as I said, complex array will require again, like if you are saying Z is a complex quantity Z10, then 20 storage computer reserves for it. So, program complex MA here, implicit none, complex dimension 2, 2. So, that is the two-dimensional ACB. So, what I am doing? Hello? Yes? I'm in the lecture, so you should rather attend the lecture and calling from there. Okay, we'll talk later. Complex dimension 2, 2. So these all will be taken as a complex quantity. So you see it's a 4. 2, 2 means 2 by 2. And that will be double of it. So 8 storage required for ACB. So the matrix that you write will be, so I'm giving the integer ij, and data that is required is A, since its dimension is already given here, is a complex. So I can write A as 2.2, 5, 1, -2, 3, 0. So these complex number can also be stored like this. That you can see that the data which you used, if you declared A as a data, then complex number can be given in this way. Now read the value, this B value, you can read the B value and write Bij, and similarly you can write the values by implied do loop here. So the values will be stored here, taking one value, then all the two values, taking second value and all two values. So, and then you can add it. You can write in the same manner using double format. So complex quantities can also be, is a good. Let's take a very simple program for a complex. Write a program to compute the value of a transfer function, which is 100, I is I omega star, 1 plus I omega, and then multiplication is done, and then this function. Now take the value of the function w or omega, like omega 0, s times omega 0, s square times omega 0. So change. So calculate all these functions unless it's become greater or equal to z value. So some quantity you have to check here. So the values of these have given in a file with a format 3f10.5. So like if I give you a problem, this will be something like there is a transfer function for different values of w, calculate this, read this value, initial value omega 0, s and z given in a file, and use the format 3f10.5 here. So first thing you have to declare here, since t is a complex quantity, so you can declare complex C1, C2, C3 and T1. So I am assuming that I read this because it's a real, so I need only 3 formats here. Then I make complex quantity. Now there are 3 types of quantities. So 0.0 real part, then only W or omega. C2 is a 1.0, and then you can see this quantity is complex. So first this is complex, then this is complex, and this. So I made this quantity over here. Then T is written as 100.0 divided by C1 complex, C2 complex, C3. So I defined it and divided it. Then it can write W and T. For each value of W, you can write the value of the complex transfer function. So it writes here. Using the format, you can see for T is a complex, so I have to give a double format here, while I have given a format, single format for this. And then every time I make this and then calculate, now this is the check is that it should be great until the value becomes Z. Z is a some number, real number. So if W is less than Z, go to 55. So that means if it is less than, then do this calculation again and again and write down every time for each value of this. And then stop. Once it is not satisfied, it becomes then stop and end. So you see, that is how you have to make a complex program and do it. Okay, so any question so far?
Excuse me, sir.
Yeah.
Sir, can you tell what does this 9 indicate?
What?
Right 9,99. So the first 9 indicates what?
First 9, as I told you, that it requires a file to be opened, and that is unit. Unit is equal to 9. Then you will write file equal to some name of the file, which is assigned 9 unit number, and then according to the file, according to the statement 99. So first 9. Yeah, I told you many times. So I think now when you will start doing making program, then it will be familiar. So I'm not opening file here, but I should have opened in the beginning, right?
Okay, sir. I understood, sir.
Any question? Okay, so anyone, if you have any question, you can ask me here.
Sir, will you share the slides?
कौन सी slide? हाँ. You want me to share?
I think these ones are already shared, I guess.
Share means with where to say share. Here now?
I'm asking about the PPT, sir. Like on the, mail or something on MS Teams.
I told you this is available in the class material. So the PH, you may note down, PH N 103 lecture part 1. PHN 103 lecture part 2. That I was following, and I will follow again in the next lecture. And the complex function lecture is already there. So whatever I taught you today will be in this file. So there are 3 files that you have to see. You better note down, everyone, and this is I have uploaded already in the class material. You can go and check there. Many of you might have seen, isn't it?
Yes, sir.
Yes,
okay.
I've seen.
PDF file is attached there. I'm not attaching their PPT file, PowerPoint, and I have attached. So everyone can note down PHN 103, lecture part 1, and the lecture part 2 is still in the process. And then today, whatever complex Fortran programming is also there. So the next lecture will be tomorrow. It is 2 to 3. Probably you have to be ready by the next week. Next Wednesday, the lab classes will start. You can seek the help of the Vendu Mahato. If you have any problem in making the downloading the Fortran on your window, because then only you can work in the laboratory class. So the first day, I think on Wednesday, the group S7 plus all the improving students or repeating students should join, and the others should wait for that. But they should join at 2 to 3 p.m. when I take the numerical analysis lecture. On the Friday, the S5, S6 section should join at 11 to 1, and then all students should join 2 to 3 lecture on Friday. Is it clear to everyone?
Sir, so S5 and S6 batches will start their practical classes this week itself or next week?
No, next week. I think I have still tell you. So Friday, I will tell you, but I think I have still 2 lectures to go. Let's do it from the next week.
All right, sir.
Okay, so it's certain that next week we start. So everyone has to come on Wednesday. There will be no class on Tuesday, 3 to 4. Only the lectures will be on numerical analysis. And then, because then I have to devote time on this. So Devendu and IUC will be there to help you while you are doing calculation. And you can share your program, make your program, work for the 2 hours, and then that will be followed by lecture. So I will lecture you. I will be available, but not sure entirely. So, but mostly I will be available. Okay, is it clear to everyone how things are going to go?
Yes, sir.
Yes, sir.
Okay. So now you can go to your next lecture. If you have questions,
Sir,
just tell me. हाँ, बोलिए.
कंफर्म कर दीजिए ना सर, मेल मिला कि नहीं आपको?
नहीं तो वो मुझे देखना पड़ेगा ना. I have to see. Okay, you can wait if you want.
Okay, sir. I'm waiting.
Okay.